Hey guys, welcome back. We have reached the end of chapter 1, and so today we're going to do the study guide for the chapter 1 test. Okay? So hopefully you have your study guide already printed or you got a copy from me in class. Let's go ahead and take a look at the first problem. Now for numbers 1 through 8, you are just solving the inequality and graphing the solution. All right, so please don't forget to do the graphing part and make sure you show all your work. All right, let's go ahead and copy number 1. So here, oops, sorry about that. Whoa. All right, so here we have absolute value of 9 plus 10p minus 1 is less than or equal to 20. So again, you want to isolate the variable, which is p. So your first step is to add 1 to both sides. And this is going to give you the absolute value of 9 plus 10p is less than or equal to 21. At this point, we can separate this into a compound inequality. We take off the absolute value signs. This becomes 9 plus 10p less than or equal to 21. This sign less than is an and statement. Refers to an and, so we're going to put an and here. And then we have 9 plus 10p. Flip the sign and take the negative of the constant. So we're going to solve this one. We're going to subtract 9 from both sides, and that will give me 10p is less than or equal to 12. Okay, and then we divide both sides by 10. So p is less than or equal to 12 over 10, which can be reduced to 6 over 5. And we're going to do this side. We're going to subtract 9 from both sides. That goes away. We're left with 10p greater than or equal to negative 30. Divide both sides by 10. So we have p greater than or equal to negative 3. All right, and then we have to graph it. Because this is an and compound inequality, we can actually put this together. The smallest value is negative 3, so we would put negative 3 less than or equal to p, which is less than or equal to 6 over 5. All right, you can write it like that, or you can write it like this. Now, if you do write it like this way right here with the two separate inequalities, make sure you put your and statement. Okay? So let's go ahead and just put a negative 3. I'm not going to count the dotted, the different squares. I'm just going to put it more or less where it goes. 6/5 is 1 1/5, so here we would have 1. So it's going to be a little bit past 1. So right around here. All right, and it is including 6/5 and then negative 3 also including that, and it is everything in between. Okay. So that's close enough. Now in the actual answers, it does give you the number line, so it's all nicely done. So you'll have at negative 3, and then a little bit past 1, we're going to put it right around there, and then everything in between. So you would write that. And then you would put either this one or this one. I'm going to use the one where they're all together. Negative 3 less than or equal to p less than or equal to 6 over 5. So this would be your final answer, but definitely you would have to show me the work. Okay? All right, let's take a look at number 2. So I'm going to go ahead and write number 2 over here. This one's negative 9 plus absolute value of 3k plus 6 less than 18. And once again, we want to solve, in this case, for a variable. This is the variable k. So the first step is to add 9 to both sides. Right? We're going to get rid of this. This will leave me with the absolute value of 3k plus 6. And that's going to be less than, this is 27. Okay? Now we're going to break this apart into 2 separate compound statements. We're going to have 3k plus 6 less than 27. This is a less than sign, so once again we have the and. 3k plus 6, flip the sign, and take the negative of the 27. Okay, here we will subtract 6 from both sides, and we'll be left with 3k less than 21. Divide both sides by 3, and we have k is less than 7. And over on this other side, again, we have the and statement. We're going to subtract 6 from both sides, and we'll be left with 3k greater than negative 33. We divide both sides by 3, and k is greater than negative 11. All right. Again, because this is an and statement, we can combine all of this together, and this looks like this. Negative 11 is less than k, and k is less than 7. Okay? And then to graph it, in fact, let's put it over here. Negative 11 is less than k, which is less than 7. All right. In order to graph it, negative 11 is over, oh, let's see, hold on. They're counting, it looks like, by 2's. So this is negative 10. Negative 11 would be between here and negative 12, and it is an open circle. Oh, darn. Sorry, it's supposed to be an open circle. Open circle. Okay, at negative 11. And then at 7, so this is 4, this is 6, 7 would be around here. I'm going to put it down here just so you can see it. So between the 6 and the 8, you have your 7. And then it's everything between those. Oops, sorry about that. Gosh, that looks horrible. All right, between negative 11 and 7, notice that they're both open circles. Obviously, you would do this on the top of the number line and not under it like I did, but I kind of messed it up. And I didn't use a pencil, so that's why we only use pencils on tests, right? Okay, number 3, I'm going to go ahead and write that one down. For number 3, we have absolute value of negative 5 minus 5n plus 3 less than or equal to negative 37. Okay, so once again, we're going to solve for a variable. In this case, it's the n. And I'm going to go ahead and subtract 3 from both sides. And this will give me the absolute value of negative 5 minus 5n is less than or equal to negative 40. Okay? We're going to go ahead and break this apart then into the 2 compound inequalities, separated into negative 5 minus 5n less than or equal to negative 40. Again, this is an and. Negative 5 minus 5n. Flip your sign and take the opposite of negative 40. which is positive 40. And we solve over here. We're going to add 5. So I'm going to get negative 5n less than or equal to negative 35. And then we're going to divide both sides by negative 5. So once again, flip your sign. N greater than or equal to 7. And here we're going to add 5 to both sides. We're going to get negative 5n greater than or equal to 45. And we're going to divide both sides by negative 5. Again, you're going to flip your sign. N is less than or equal to negative 9. All right, so remember, when it's an AND statement, both of these things have to be true at the same time. So if I have 7 here and I have n is greater than or equal to 7, that's everything that way. And if I have a negative 9 over here and I say that n is less than or equal to negative 9, where do these guys intersect? Well, they don't. And remember is an intersection, where OR is a union. You put everything together. So these two guys do not intersect, so your answer is no solution. And then you would go back over here and there would be nothing here, and then the only thing would be no solution. Okay? All right, let's take a look at number 4. Let me see, absolute value of 3x plus 5 plus 6 less than 35. Let's take a look at that guy. Okay, so here we go. Again, we want to get this x by itself. The first thing we got to do is subtract 6 from both sides. This is going to give me the absolute value of 3x plus 5 is less than 29. Okay, break this apart into a compound inequality. It would be 3x plus 5 less than 29. This is also an AND. 3x plus 5 greater than negative 29. Remember, the second part, we flip the sign and we take the negative. All right, we're going to subtract 5 from both sides, and we're going to get 3x is less than 24. Divide both sides by 3. X is less than 8. And over here we're going to subtract 5 from both sides. Oh, there's Charlie. Wouldn't be a day without Charlie barking. 3x is greater than negative 34. We're going to divide both sides by 3. So x is greater than negative 34 over 3. So once again, because this is an AND statement, we can combine everything. The smallest number, or the smallest value, is negative 34 over 3. And that's going to be less than x. And x will be less than 8. Okay? So let me go ahead and write that over here. Let me just copy it. Negative 34 over 3 is less than x, which is less than 8. Now, when we graph this, 34 over 3, that's going to be 11. 36 would make it 12. So this is 11 and 1/3. Double check that. Sorry. Yeah, that's going to be 34. So this is negative 11 1/3. So when I go over here, here's negative 11, and it's just a smidgen over. So now remember, this is going to be an open. So close to negative 12, but not quite there. And then 8 is also going to be open. Good, this one I did correct. Yay! And everything in between. Okay? All right. Let's take a look at number 5. All right, let's go back here. Sorry. So for number 5, we have 10 plus absolute value of 9 minus 3r less than 1. So again, we're going to isolate this r, so I'm going to subtract 10 from both sides. And now guys, remember, this is all Algebra 1, what you're doing right now. In fact, I know the Algebra 1 classes are actually doing this exact same thing right now. 1 minus 10, that's going to be negative 9. Okay? And if you're looking at this, if you step back for a second, you can see that this has no solution because the absolute value of whatever you do, whatever is in there, has to be greater than or equal to 0. It can never be less than a negative number. But let's say you didn't see that, okay, that you didn't see it, so you'd go ahead and separate this into 9 minus 3r less than negative 9, and this is also an and, 9 minus 3r greater than positive 9, and you would solve for r, and you're going to get some sort of nonsense that doesn't make sense, and that's going to tell you that it is a no solution. So this is going to give me negative 3r is less than negative 18. Divide both sides by negative 3. And this is going to give me r, flip your sign, is greater than 6. And over here we're going to subtract 9 from both sides. That's going to give you negative 3r is greater than 0. Divide both sides by negative 3. Remember, you must flip your sign. R is less than 0. So in what math world can r be less than 0? That means going that way. And also be greater than 6. Well, nowhere. So that'll tell you that it is no solution because this makes no sense. Okay, so then for number 5, your answer again is no solution. When it's no solution, you leave the graph alone. Please don't touch it. There's no answer there. Okay? All right, number 6. Let's copy this one down. Give me just a second. Absolute value of 4x plus 2 minus 4 greater than negative 14. All right. Let's take a look at number 6. Again, we're solving for this x, so I am going to add 4 to both sides. And again, this should all be reviewed. This is all Algebra 1. There's nothing new here. And negative 14 plus 4 is negative 10. Now, for those of you that are smarty pants and you're looking at this and you're seeing the absolute value of something is greater than a negative number, well, obviously that's true, and that's always going to be true. So your answer here is all real numbers, but let's say you didn't see that. So we're going to separate this and find compound inequalities that actually will give you the entire number line as a solution. So that's going to be 4x plus 2 greater than negative 10. Now this is an OR. Remember, ORs are unions, so when we do the graph we have to put everything together. We have 4x plus 2. Flip your sign and take the negative of the 10. Take the negative of the negative 10, which makes it positive 10. And here we will get 4x greater than negative 12. Divide both sides by 4. X is greater than negative 3, or Here we're going to subtract 2 from both sides, so 4x is less than 8. Divide both sides by 4. X is less than 2. So let's see what that looks like on a graph. At 2, you want x is less than 2. So it does not include the 2, but it's everything less than it. And then x is greater than -3. Does not include the -3, but it's everything greater than it. So hopefully you can see that if you put these two things together, because the OR is a union, right? You bring them together, you're going to get the entire number line. So for your answer for number 6, oops, where did I go? Sorry. You are going to put all real numbers. You can also just put all real numbers, but you do have to draw the line over the entire number line. So that is your solution set for number 6. Okay? Let's go to number 7. Let me write this one down. For number 7, we have 10 times 9 plus 10x less than or equal to 90. All right, so this one's got something other than addition or subtraction going on over here. There's multiplication by 10. So to get rid of a multiplication by 10, we divide both sides by 10. And this will give me 9 plus 10x less than or equal to 9. All right, we're going to break this one up into two different inequalities. Less than or equal to 9. This is an and over here we have 9 plus 10x. Flip your sign and get the negative of the constant over there. I'm going to subtract 9 from both sides. 10x less than or equal to 0. Divide both sides by 10. X is less than or equal to 0. And over here, I'm going to subtract 9 from both sides. 10x greater than or equal to -18. I'm going to go ahead and divide both sides by 10. So x is greater than or equal to negative. Now I do have to reduce this. I'm going to divide the numerator and the denominator by 2. That's going to give me 9/5. Because this is an and, we can put it all together. So the smallest value is -9/5, and x is greater than or equal to that, so that means -9/5 is less than or equal to x, and then x is less than or equal to 0. Okay? Let's write that down over here. So -9/5 less than or equal to x less than or equal to 0. And then when we get ready to graph it, we obviously have 0, and it is included, so that you want to make sure you color that in. Now -9/5, you're almost at -2, so very, very close, because -10/5 would be -2. So we're like really, really close, and it's everything in between. All right. Okay, number 8. Let's do this one. Absolute value of 10a minus 10 minus 4 greater than or equal to 26. All right, so here we're going to add 4 to both sides. And this is going to become absolute value of 10a minus 10 greater than or equal to 30. And now we're going to break this guy up into two inequalities. 10a minus 10 greater than or equal to 30. Now because this is greater than or equal to, this is actually an OR, which means we do the whole union thing. We take everything. And over here we have 10a minus 10. We flip the sign and take the negative of the constant. So I'm going to add 10 to both sides. I'm going to get 10a greater than or equal to 40. Divide both sides by 10. A is greater than or equal to 4. Or I'm going to add 10 over here. This is going to give me 10a less than or equal to negative 20. Divide both sides by 10. A less than or equal to negative 2. Now remember, this is an OR. So let me put it over here. We're going to write A greater than or equal to 4, or A less than or equal to negative 2. So A greater than or equal to 4. 4 is right there. It does include the 4, and it's greater than or equal to. Or A is less than or equal to negative 2. Negative 2 is right over here, and it's everything this way. Remember, ORs tell us to combine everything together. It's the ANDs where we take the intersection. Okay? All right, well, that was problems 1 through 8. Now, for the next problems, which you will see on the next page, you're going to do several things. You're going to graph the function. You don't need to give me the parent function, just the function that I'm giving you, just the transform function. No need to give me the parent. But you do need to, you don't need to sketch the parent, but you do need to tell me what the transformations are that occurred with this function with respect to the parent. So what were the transformations? Where's the function positive? Where's the function negative? Where is it increasing? Where is it decreasing? And what is the end behavior? Don't worry, I wrote this on your test, so you're not going to forget what you need to give me. All right? Okay, so now let's go to number, actually I'm going to separate this. Let's go to number 10, because number 9 actually were these instructions, so just ignore that. Okay, so in order to graph this, it's nicely given to you in vertex form. So you should easily be able to tell me what the vertex is, and you go here. Inside the function, it's the opposite of what you see. You see a negative 4, your vertex is going to be positive 4, and then the negative 3 does stay the same. All right? And then we're going to pick two values smaller than 4, so 3 and 2 values larger than 4, so 5 and 6. Another thing I want you to make note of, there's a minus here. That means this is an upside down absolute value. By the way, these are all absolute values. Please don't graph them like quadratics, because yeah, that'll scare me a lot. So please realize everything here is absolute value. All right, so we go to the vertex, which is at 4, negative 3. All right, and we know it's going to open down. So let's plug in a 5. Let's see if I put in a 5 here. Let's see, negative 2, absolute value of 5 minus 4 minus 3. You do order of operations, so we're going to take care of what's in these grouping symbols first. 5 minus 4, that's 1. The absolute value of 1 is 1. 1 times negative 2, that's negative 2 minus 3. That's going to give me negative 5. So when x is 5, y is going to be negative 5. So let's do that. Okay. Now, the beautiful thing about this guy is that it's going to be symmetric, right? We know that the vertex is at 4, negative 3. And you probably remember this. This is your axis of symmetry. Your axis of symmetry must be at 4 also. So this function is going to be symmetric. So whatever you see here, you're just going to copy it right over there. You could, if you wanted to, just fill it all out. do 3. 3 minus 4, that's negative 1. Absolute value is 1. 1 times negative 2 is negative 2. Negative 2 minus 3 is going to give you negative 5. Oh no, what is happening to my monitor? Hold on, guys. Sorry about that. It's going to be negative 5. I think it's just going to sleep. I better change the settings on it. So you'll see that if you put a value for 6, it's going to be the same for 2. In case you wanted, you could just check it, but really no need at this point. So we have the graph, which is the first part, and then the instructions say, okay, graph the transformed function, label it, so they want you to label it. This is y equals negative 2 times the absolute value of x minus 4 minus 3. What are the transformations that occurred with respect to the parent? So transformations. Let's see, can you tell me what they are? Well, there are 3 of them, and you can give them to me in whatever order you want. So reclection over x-axis, that's 1. 4 units right, and 3 units down. Okay? All right, so we did what are the transformations. Where is the function? Positive, negative, increasing, decreasing. All right, this is where we need space. Positive, negative, increasing, and decreasing. All right, this function is never positive. It's never going to be above the x-axis. So for positive, we're going to put not applicable. Negative, the entire function is below the x-axis, so all of it. So all real numbers. You can either write all real numbers or just the symbol. Increasing, remember the little guy that I told you about as he's walking towards the function? When he gets here, the function starts increasing until we get to the vertex, which is 4, negative 3. So it is increasing while x is less than 4. And then once the little guy reaches the top, he starts sliding down, so it is decreasing when x is greater than 4. Okay? And the last thing we need is end behavior. So I will give this to you. I'll give you as x goes to positive infinity, and then you need to tell me where the function's going. And as x goes to negative infinity, again, you're going to tell me where is the function going. So as x goes to positive infinity, our function is going down. It's going to negative infinity. Negative infinity along the y-axis, right? As x goes to negative infinity along the x-axis, the y is also going to negative infinity. So this one is going to be both of them. F of x goes to negative infinity and f of x goes to negative infinity for both. Okay? And it makes sense. It's going down and down. All right. Wow, that was a lot. Let me just double check, make sure we got everything. Function negative, positive, increasing, decreasing. Yeah, and end behavior. Perfect. All right, so that's one of them. Don't worry, the actual test does not have this many problems, but I did want you to practice for the study guide. All right, again, we're going to look for the vertex, and since this is in vertex form, it's really easy to spot. It's going to be 2, 1, right? We take the opposite of what's inside the function. I'm going to get 2 values that are smaller, so 0 and 1, and 2 values that are larger, so 3 and 4. Again, just like number 10, this one is a negative, it's got a negative a value out here, so it is going to be opening down like that. So immediately you should know, because it's absolute value, that the end behavior is going to be negative infinity, negative infinity. So that's pretty straightforward. All right, so we go to 2, 1. That's our vertex, and we know this is going to open down. Let's plug in a 4. 4 minus 2, that's 2. The absolute value of 2 is 2. 2 times negative 2 is negative 4. And negative 4 plus 1 is negative 3. So at 4, this is negative 3. And because of symmetry, we know that at 0, it will also be negative 3. 1, 2, 3. And then we'll plug in a 3. 3 minus 2, that's 1. The absolute value is 1. 1 times negative 2 is negative 2. And negative 2 plus 1 is negative 1. So this one is negative 1. So at 1, we're at negative 1. And at 3, we are at negative 1. Connect your dots. Oops, sorry about that. Close enough. We're done with the graphing part. Let's talk about the transformations. Again, you can give them to me in any order, and there are 3 here. So it's a reflection over the x-axis. It is 2 units right and 1 unit up. Okay? Easy peasy. Then we're going to talk about positive, negative. Let's see if I can fit it in here. Okay, so positive. Where is this function positive? Well, right over there. Now, because it's positive up there, we're actually going to need to find these x-intercepts. Something that you should be familiar with from Algebra 1, but maybe you've forgotten. So we need to find out what these points right here are, because I don't know what they are right now from what I'm seeing. So how do we find the x-intercepts? I'm going to take you to another sheet of paper. In order to find the x-intercepts, in order to find x-intercepts, and when I'm talking about intercepts, any type of function, you're going to let y equal 0, and you're going to solve for your x. Okay? So let's have the actual equation up here, or the function here. It's y equals negative 2, absolute value of x minus 2 plus 1. So we are going to let y be 0. Okay? And we're going to solve for x. I'm going to subtract 1 from both sides. And again, this is a little tricky, but not terribly, because you did do this before. And now I'm going to divide both sides by negative 2. So 1/2 is equal to the absolute value of x minus 2. All right, I'm going to just rewrite this way because it's just easier for me to do that. We break this up into x minus 2 equals 1/2, or x minus 2 equals negative 1/2, right? If this is true, x is equal to 2.5, or x equals, here we're going to add 2, so 1.5. So these are our x-intercepts. It's crossing at 1.5, and it's crossing at 2.5. So you can kind of see it. I may be off a little bit here, right? But it is at 1.5 and 2.5. So where is this positive? It is positive between 1.5 and 2.5. Yeah? Not including 1.5 and not including 2.5, because at those 2 points, it's crossing the x-axis, so its value is actually 0. All right? Where is it negative? It's going to be negative when x is less than 1 and 1/2, right? This part down here. and when x is greater than 2 1/2. So the negative part has two parts to it. And the only thing that makes this a little difficult is that these are fractions, but other than that, not a terrible thing. So that's where they're positive and that's where they're negative. And now we need increasing and decreasing. So here's the little guy. As he's walking towards a function, he's going to go up. So it is increasing until it reaches the vertex, and the vertex is at 2, 1. So it is increasing when x is less than 2, right? Everything here, it's increasing, increasing, increasing. When it reaches a vertex, it stops and it starts going down. So it is decreasing when x is greater than 2. Yeah? Okay. And last but not least, end behavior. I can tell you right now, it's going to be identical to this one because it's opening down and down. But here we go, end behavior. As x goes to positive infinity, our function is going, although the function is called y here, we just call it y equals. I'm calling it f of x just to get you accustomed to it, because that's how we normally refer to functions in Algebra 2 and above. So we'll give it the function notation. And as x goes to negative infinity, our f of x is also going to negative infinity. Again, the same as this one, down and down. Those are the end behaviors. Okay, so this one was a tiny bit trickier because you had to find your x-intercepts. Will it be on your quiz? I don't know. It's on your test? I don't know. It's the luck of the draw. It's a random problem generator thing. So maybe you'll get an easy one. Maybe you'll get one where you have to find the x-intercepts, in which case you know how to do that. Again, that is from Algebra 1. Okay? All right, number 12. Let's take a look at number 12. Here the vertex is really easy. It's at 0, -4, right? Because this is the same as saying 2 times the absolute value of x plus 0 minus 4, right? So it's 0, -4. I'm going to find some values, get some numbers that are smaller than 0, so -1 and -2, and bigger than 0, 1, and 2, and plug those in. So if I plug in a 2, the absolute value of 2 is 2. 2 times 2 is 4. 4 minus 4 is 0. I plug in a 1. Absolute value of 1 is 1. 1 times 2 is 2. 2 minus 4 is -2. Plug in a -1. Absolute value of -1 is 1. 1 times 2 is 2. 2 minus 4, -2. And this one should be -4 because of the symmetry. All right? So we're at 0, -4. Now this one is positive A, so this is going to open up. We know that. And at -2, we are at -1, 2, 3. Oh, wait. At 0, sorry, never mind. At 0, okay, give me just a second. At 0, we're at -4. At -1, we're at -2. I don't know what I put here. So sorry about that. I'm like, what is that? Sorry, that should be 0. This one goes with this one, and this one goes with that one. So sorry about that. So at -2, we have 0. At -1, we have -2. At 0, we have -4. At 1, we have -2. And at 2, we have 0 again. All right, looks a lot better. It's a little weird there. All right. Okay, so now we have that. Now this one's nice because we have our zeros here. We have zeros at x is -2 and at x is 2, so we don't have to go through what we did with the previous one. All right, transformations. Here I see only 2 transformations. I see a vertical stretch by 2, and 4 units down. Okay? Let's see, we need positive, negative, increasing, decreasing, and then end behavior. So positive, well, that one's easy. This thing is positive up here and over here. And we know the x-intercept, one is at -2 and the other one's at 2. So this thing is positive when x is less than -2. It's also positive when x is greater than +2. And it is going to be negative between -2 and 2. And it does not include them because remember, at -2, this is 0 and that is 0. All right? Increasing, decreasing. Pretend you're a little man. You're walking towards a function. You hop onto the function. You're going to decrease until you get to the vertex. The vertex is at 0, -4. So it is decreasing until we get to an x value of 0. So when x is less than 0, this guy is decreasing, and he starts increasing when the x value becomes greater than 0. All right? And we need the end behavior. Now this one is opening up and up, so I'll tell you right now, the end behavior is going to be positive infinity, positive infinity. Oops, sorry about that. Sorry, I'm getting some messages here on my computer. Not right now. So, as x goes to positive infinity, f of x will go to positive infinity. And as x goes to negative infinity, f of x is still going to positive infinity, up and up. Those are your end behaviors. Okay? All right. I know it's a lot, guys. I'm sorry, but I just to be to let you know, the actual test only has 7 questions. So I know I did a lot for the study guide. All right. Let's go to number 13. I want to make sure you're practiced and you know what you're doing. So the vertex here is going to be +4, -2. We're going to get some values here. The vertex is at 4, -2. Look at 3 and at 2 and at 5 and at 6. So let's plug in a 6. 6 minus 4, that's 2. Absolute value is 2. 2 times 2 is 4. 4 minus 2 is 2. If it's 2 at 6, it's going to be 2 at 2 because they're equidistant from the vertex. So at 6, we are at 2, and at 2, we are at 2. Plug in a 5. 5 minus 4, that's 1. Absolute value is 1. 1 times 2 is 10. Wait. 5 minus 4, sorry. 5 minus 4 is 1. It's late, guys. I am so sorry. 5 minus 4 is 1. Absolute value is 1. 1 times 2 is 2. 2 minus 2 is 0. And so that means that at 3 we also have our 0. And that's really great because we know what our x-intercepts are, and life will be easy for us when we now do positive and negative. Okay? All right, so now we're going to do transformations. I see 3 transformations. I see a vertical stretch by 2. I see 4 units right, and I see 2 units down. All right, that's the transformation part. Let's do positive, negative, increasing, and decreasing. All right, so this thing is positive here, and here. And we know what the x-intercepts are. They're at 3 and 5. So the function is positive when x is less than 3, and it's also positive when x is greater than 5. So x less than 3, x greater than 5. It is going to be negative down here under the x-axis between 3 and 5, not including them. Okay? Increasing, decreasing, again, think of the little man walking towards a function. It is going to decrease until we reach the vertex, which is at 4, -2. So it is decreasing when x is less than 4. Once it reaches 4, it starts increasing, so x greater than 4. Notice it's strictly greater than or less than. It does not include 4. At 4, the x value is neither increasing nor decreasing. It's changing direction. Okay? The function is changing direction. End behavior. Let's see if I can squish that in here somewhere. Obviously, it's going to be positive infinity, positive infinity. So as x goes to positive infinity, again, I will give this to you. All you have to write is positive infinity. And then as x goes to negative infinity, again, f of x goes to positive infinity. So these are the two things you're going to write. Okay, so pretty straightforward. Any questions? Oh, of course there are no questions. You're watching this on video, sorry. Yeah, this is what happens to Miss Perez when she's been doing math all day and it's pretty late. Sorry about that, guys. All right, obviously no questions. Let's move on to the last page of this first part. Again, there's another part, and I'll do a separate video for that one because I think I need a break and maybe get some coffee or something. Number 14, we're going to go ahead and find the vertex here. The vertex is going to be at 0, 2, again. We know this already. We also know this is going to open down. All right, so I'm just going to get a few points for it. Vertex is at 0, 2. Let's do -1, -2, 1, and 2. If I plug in a 2, the absolute value of 2 is 2. 2 times -3, that's -6. Plus 2, that's -4. That means over here we have a -4. Plug in a 1, that's going to be the absolute value of 1, which is 1. 1 times -3 is -3. -3 plus 2, that's -1, -1. All right, good enough. So we have 1, -1. We have -1, -1. We have 2, -4, and -2, -4. All right, transformations. Here we do have 3 transformations. We have reflection over x-axis, that's the minus sign. We have vertical stretch by 3, and we have 2 units up. Okay? Just double check to make sure I'm answering. Give me just a second, guys. I want to make sure I'm answering all the questions. So we had then positive, negative, increasing, decreasing, and end behavior. All right, where is the function positive? Okay. This one is going to give us a little problem. We're going to need, this is another one where the x-intercepts are unknown because they're not nice numbers. That means they're going to be fractions, and that's okay. So in order to do positive, negative, we're going to need to find the x-intercepts first. So we're going to set this to equal 0. So y is going to be 0. So let me just do it down here. I have y equals negative 3 times the absolute value of x plus 2. We're going to set the y to 0. And we're going to solve. So I'm going to subtract 2 from both sides. I'm going to get negative 2 equals negative 3 absolute value here. Divide both sides by negative 3. And I'm going to get the absolute value of x equals 2/3. Well, that means that x is either positive 2/3 or x is negative 2/3. And these are in fact the two x-intercepts. All right? So we're going to need that for when we do positive negative. So this is, I can't even know if I can fit that in there. Let me see what I can do. Here, that point is going to be positive 2/3, and that point is going to be negative 2/3. Okay? All right, so the function is positive between negative 2/3 and positive 2/3, and everything in between, right up here. This is where it's positive. The function is negative when x is less than negative 2/3, and it's also negative when x is greater than positive 2/3. Yeah? Increasing, decreasing. If we are a tiny human and we're walking along, we bump into the function, we're going up. So we're going to be increasing, and this is your vertex, by the way, at 0, 2. So we're going to be increasing when x is less than 0. The function is going up. Remember, we read these things from left to right. Function is going up. Then it hits 0, and then the little man starts falling down. So it'll decrease when x is greater than 0. Okay? And then end behavior we can see is going to negative infinity, both of them, but I'll write it out. So as x goes to positive infinity, f of x is going to negative infinity, and as x goes to negative infinity, f of x still goes to negative infinity. Remember, this is constant for everything. So I'm going to give you that, and you just need to fill in this part right here. But if it's both going down, they're both going to negative infinity. Okay? Alrighty. Let's take a look at this one. Alright, the vertex here. There is no k out here, so we can just put a plus 0. So my vertex is at negative 2, 0. Negative 2, 0. And this guy is going to open up because it's positive. So we know we're going to have this situation. Which, by the way, the end behavior immediately you can see is going to be positive infinity, positive infinity. Alright, let's do this. So we have x comma y. We have negative 2, 0. We're going to pick values that are smaller than negative 2. So let's do negative 3, negative 4, and bigger, negative 1 and 0. Alright, let's start with, why not, negative 4. Negative 4 plus 2, that's negative 2. Absolute value is 2. 2 times 2 is 4. So at negative 4, you are at 4. Now if that's true there, that means that at 0, we are also at 4 because of the symmetry. So 0 plus 2 is 2. Absolute value is 2. 2 times 2 is 4. So that is true. At negative 3, if I plug in a negative 3 plus 2, that's negative 1. Absolute value is 1. 1 times 2 is 2. So at negative 3, we are at 2, and that means that at negative 1, we are also at 2. Now, this one, because not only is the vertex, it's also the x-intercept. It's where, it's the value of x where the y value is 0. So that's really great for us. Oh, I forgot to put here too. Okay? And we're going to use that. We don't need to do anything crazy for that one. So transformation or transformations. There's 2. There's a vertical stretch by 2, and there is a shift 2 units left, because it happens inside the function, and you can see it. It's shifted 2 units to the left. Okay? Positive. Where is the function positive? Well, this one's a little, I'm going to say, because the function here is technically on the x-axis, so it's neither positive nor negative, this particular point. The rest of the function is positive everywhere. I'm going to say it's positive for all real numbers except when x equals -2. And the reason is, at -2, it's not positive. It's 0. So for positive, we're going to put all real numbers with the exception of x being -2. That's going to be excluded. For negative, that one's easy. It's never going to be negative, so not applicable. Increasing and decreasing. All right, remember, you're the little guy coming towards the function. Boom, 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 boom. You're sliding down. So you're decreasing until you get to the vertex, which is at -2, 0. So you are decreasing when x is less than -2, and then you begin to increase when x is greater than -2. Okay? And the last part is end behavior, and again, here we see it going up and up. So as x goes to positive infinity, f of x goes to positive infinity. As x goes to negative infinity, f of x still goes to positive infinity. All right, guys, that is the end of the first part of the review. I'll be back with a video on the second part in just a few minutes. Thank you.